Hello, this is Gauri. Let's begin with the introduction. We have already discussed about the law of variable proportion and returns to scale which underline the process of production. We have dealt with the way total output behaves to a change in all the factors of production, which is known as law of returns according to scale of production. According to this law, when all factor units are increased, total product may increase at an increasing rate, later at a constant rate, and finally at a diminishing rate. These three tendencies have come to be known as increasing returns to scale, constant returns to scale, and diminishing returns to scale. Further, we will incorporate the study of factor pricing, wherein there is optimum factor combination, or we can even term it as a least cost combination of the factors of production. This will also include the expansion path, showing the different choice of inputs. We have already discussed the concept of I-sequence, which in economic terminology means a graph of all possible combinations of inputs that result in the production of a given level of output. It helps to measure the influence of inputs on the level of production or output that can be achieved. We shall further discuss the isocost curve, which could be understood as the locus traced by the various combinations of L, that is labor, and K, that is capital, each of which cost producer the same amount of money. The isocost line will shift to the right when money spent on factors increases or firm could buy more as the factor prices are given. In short, the concept of isocost can be taken as the factor prices. Responsiveness of the buyers of a good or service to the price changes in its substitutes. It is measured as the ratio of proportionate change in the relative demand for two goods to the proportionate change in their relative prices. Let's begin with optimum factor combination or least cost combination of the factors of production, which we call expansion path. Choices of inputs. Factor prices can be explained as the meaning of factor price in economics can be taken as an effort to explain the principles by which a business firm decides how much of each commodity that it sells, its output or products, it will produce, and how much of each kind of labor, raw material, fixed capital good, etc. that it employs, its inputs or factors of production, it will use. The theory involves some of the most fundamental principles of economics. These include the relationship between the prices of the commodities and prices or wages or rents of the productive factors used to produce them, and also the relationship between the prices of commodities and productive factors on the one hand, and on the other hand are the quantities of these commodities and productive factors that are produced or used. Another is optimum factor combination. The prices of factors are represented by the isocost line. It plays an important role in determining what combination of factors the firm will choose for production. An isocost line is defined as the locus of various combinations of factors which a firm can buy with a constant outlay. It is also called as price line or outlay line. Let us take an example. Suppose that the firm has rupees 300 to spend on factors labor and capital, and price of the labor is rupees 4 per labor hour and price of capital is rupees 5 per machine hour. With outlay of rupees 300, he can buy 75 units of labor or 60 units of machine hours, that is capital. Let us understand it with the help of a diagram. Let OB represent 70 units of labor and OA represents 10 units of capital. Now suppose the firm spends the entire outlay of rupees 300 on capital, then it buys 60 unit or OA of machine hours. The straight line AB with joint points A and B will pass through all combinations of labor and capital which the firm can buy with the outlay of rupees 300. If it spends the entire sum on them at the given prices, equation of isocost will be C is equals to WL plus RK. the total cost incurred on the factors of production for production of a commodity is equals to the sum of the payments made by labor and capital. The payment for the labor used is equals to the wage rate, that is small w, multiplied by the amount of labor used, that is capital L. Thus, the product W dot L represents the total payment made for labor. Similarly, R dot K is the total payment made for capital, where R is the price per unit of capital and capital K is the quantity of capital used. C is the total cost incurred by the firm on purchasing the quantities of factors used for production. Thus, total cost equation can be written as C is equals to WL plus RK. Now, let us discuss least cost combination of factors. First is choice of inputs. An equal product map represents the production function of a product with two variable factors. An equal product map represents the technical conditions of production for a product. A family of iso-cost line represents various levels of total cost or outlay. Given the prices of two factors, the entrepreneur may desire to minimize his cost for producing a given level of output, or he may desire to maximize his output level for a given cost or outlay. To produce a given level of output, the entrepreneur will choose the combination of factors which minimizes his cost of production. Only in this way he will maximize his profits. Thus, a producer will try to produce a given level of output with the least cost combination of factors, and this least cost combination of factors will be optimum for him. Let us take an example. Suppose the entrepreneur had decided to produce 500 units of output, which is represented by isequent Q. The 500 units of output can be produced by any combination of labor and capital, such as R, S, E, T and J lying on the isequence. Let us understand this with the help of this figure. For producing the given level of output, which is 500 units, the cost will be minimum at point E, at which the iso-cost line CD is tangent to the given isequent. At no other point like R, S, D and J lying on the isequent Q, the cost is minimum. All other points on isequent Q, such as R, S, T and J, lie on the higher iso-cost lines than CD, and which will therefore mean greater total cost or outlay for producing the given output. The entrepreneur will not choose any of the combinations R, S, T or J. The factor combination E is the least cost combination of labor and capital for producing a given output. Hence, the entrepreneur will choose factor combination E, that is OM units of labor and ON units of capital, to produce 500 units of output. It is thus clear that the tangency point of the given isequent within iso-cost line represents the least cost combination of factors for producing the given output. Next is output maximization for a given level of outlay, that is cost. A rational producer will be interested in maximizing output of the commodity. For example, suppose the firm has decided to incur an outlay of rupees 5,000 on labor and capital, which is represented by iso-cost line AB. The firm has to choose any of the factor combinations of labor and capital, such as R, S, E, T, J, etc. lying on the given iso-cost line AB to produce the product. An isequent map showing the set of isequents that represents various levels of output, means 200, 300, 400, 500 units, has been superimposed on the given iso-cost line AB. We can see from this figure that the firm will choose the factor combination E consisting of ON of labor and OH of capital. This is because of all the factor combinations that lie on the given iso-cost line AB. Only the factor combination E enables the firm to reach the highest possible isequent Q3 and thus produce 400 units of output. All other combinations of labor and capital that lie on the given isocost line AB, such as R, S, T and J etc., lie on the lower isequence showing lower levels of output than 400 units. Therefore, at point E, the entrepreneur will have maximized output for a given cost. Moving ahead with next topic, which is expansion path. We have already explained which factor combination a firm will choose to produce a specified level of output given the prices of the two factors. Now, let us see how the entrepreneur will change his factor combination as he expands his output given the factor prices. Let us take an example. Suppose the prices of two factors, labor and capital, are such that they are represented by the slope of the isocost line AB. We can see from figure that four isocost lines A, B, C, D, UF and GH are drawn, which shows different levels of total cost or outlay. All isocost lines are parallel to each other, indicating that prices of the two factors remains the same. If the firm wants to produce the output level denoted by Q1, which is equals to 100 units of output, it will choose the factor combination E1, which minimizes cost of production. E1 being the point of tangency between the isequent Q1 and the isocost line AB. Now, if a firm wants to produce a higher level of output denoted by the isequent Q2, which is equals to 200, it will then choose the factor combination E2, which is the least cost combination for new output. For still higher output levels denoted by Q3 and Q4, the firm will respectively choose tangency combination E3 and E4, which minimize cost for the given outputs. Thus, the line joining the minimum cost combinations such as E1, E2, E3, E4 is called the expansion path, because it shows how the factor combinations with which the firm produces will alter as the firm expands its level of output. Hence, the expansion path may be defined as the locus of the points of tangency between the isoproduct curves, that is isoquants, and isocost lines, and it is known as isoscale line because it shows how the entrepreneur will change the quantities of the two factors when it increases the level of output. It has different shapes and slopes depending upon the relative prices of the productive factors used and the shape of isoquants. Since expansion path represents minimum cost combinations for various levels of output, it shows the cheapest way of producing each output. Given relative prices of the factors, it is certain that when both factors are variable and the prices of factors are given, a rational entrepreneur will seek to produce at one point or the other on the expansion path. Moving further to our next topic, that is elasticity of substitution. The isequence illustrates an important economic phenomena, that of factor substitution. This means that one variable factor can be substituted for other. As a general rule, a more lavish use of one variable factor will permit an unchanged amount of output to be produced with fewer units of some or all of the other. In the theory of production, we are concerned with the elasticity of substitution between factors or between inputs. In the production of goods, it is also termed as elasticity of technical substitution in economics. The marginal rate of technical substitution, that is MRTS, of factor x for y declines as factor x is substituted for factor y along a isequent. In other words, MRTS is different at different factor proportion, that is input ratios used in the production of a good. Its definition is the relative change in the factor proportions or input ratios as a consequence of relative change in the other is called marginal rate of technical substitution, that is MRTS, is also known as elasticity of substitution between factors. We can further explain the concept of elasticity of substitution with reference to capital and labor as factors of production. If suppose K stands for the quantity of capital, L for the quantity of labor and sigma the elasticity of substitution, then in accordance with the above definition, mathematically elasticity of substitution of capital for labor can be expressed as sigma is equals to proportionate change in the ratio of inputs, that is K and L used, divided by proportionate change in the marginal rate of technical substitution of L for K. Let us see the figure of MRTS of L for K and capital labor ratios. An isequent or equal product curve Q is drawn here. It can be seen that at point A in the given isequent Q, the capital labor ratio used is K1 by L1, which is equals to the slope of the ray OA. As labor is substituted for capital and therefore, we move down on the isequent Q from point A to B, capital takes place and we come down to point C on the isequent Q, capital labor ratio falls to K3 by L3, which is equals to the slope of ray OC. It is therefore clear that as we substitute more labor for capital along the isequent, capital labor ratio is decreasing. Thus, the concept of elasticity of substitution occupies an important place in the theory of distribution. The distributive shares of labor and capital in national income depends on the elasticity of substitution. Now, let us take a brief idea about cost function. We have already studied the production function. Now, we will further try to understand the meaning of the cost function. The cost of production of the firm depends on the nature of physical production function. The cost of production varies with the increase in the level of output of the firm. In fact, we can say that cost and level of output are related to each other. The cost function of the firm depends on the physical production function and the prices of the factors used for production and the technology used for production. We can also say that the cost of production is the most important factor governing the supply of a product. By definition, cost function expresses functional relationship between total cost and the factors which determines it. The factors that determine the total cost of production of a firm are the output Q, the level of technology T, the prices of factors and the fixed factor F. Symbolically, the cost function becomes C is equals to function of Q, T, P, F, F and so on. The economists draw distinction between the short run and long run cost. Short run cost. The short run costs are those costs which are incurred by the firm during a period in which some factors, especially capital equipment, land and management, are held constant. It is incurred on the purchases of labor, raw materials, chemicals, fuel, etc., which vary with the changes in the level of output. The short run cost function can be written as C is equals to function of Q, T, P, F and K, where Q stands for the level of output, K the capital and other fixed factors which are held constant, T the technology and it is taken as given, PF factor prices taken as given, while long run cost are the cost incurred during a period which is sufficiently large to allow the variation in all the factors of production including capital equipment, land and managerial staff to produce a given level of output. The long run cost function can be written as C is equals to function of Q, T, P, F, or we can say C is equals to function of Q, where C is total cost of production, Q the level of output and T the technology. PF is equals to the prices of factors of production used for the production of a particular product. The difference between the short run and long run cost function is that in short run the cost output relationship is studied with a certain amount of capital or land fixed, whereas in long run cost function, it examines the relationship between cost and output when capital and land also vary along with the variable factors such as labor, raw materials. In fact, in both the short run and long run cost functions, we study the relationship between the cost and the level of output, that is C is equals to function of Q. But in long run, the advancement in the technology and changes in factor prices cause a shift in the long run cost function, and in short run, besides technology and factor prices, some fixed factors such as capital or land also bring about a shift in the cost function. Thus, the long run cost function represents the use of optimum resource combination so as to ensure minimum cost of production for each level of output. And in the short run, it is assumed that given the size of the plant, that is capital equipment, the firms operate to minimize cost for producing various levels of output. Let's summarize it. Thus, today we have discussed concepts of factor price, cost minimization and output maximization. We have also discussed elasticity of substitution, expansion path, and have a brief idea of cost function. Thank you.